Hello everyone, I am Dr. K. Srinivasan, Professor, the Department of Electronics and Communication Engineering, Sri Ramakrishna Institute of Technology, Coimbatore. Today I am going to discuss the topic on LIC meets modern technologies. LIC means linear integrated circuits. How far this LIC is influencing the modern technologies like artificial intelligence, deep learning, and so on. So, in today's my presentation, I'm going to discuss the foundations of LIC, then convergence of LIC, which meets modern technologies, then role of ICs in AI and ML, then role of ICs in IoT field, then how this IC influencing the deep learning algorithms and areas, then AI powered LIC designed for smarter circuit, faster innovation, then the real time applications of linear integrated circuits. So next comes the understanding of LIC in terms of three areas like core components, analog processing, key applications. So the core components means the operational amplifier, voltage regulator, then analog signal processors form the backbone of the modern electronics. So with respect to the voltage regulator, we can have the positive voltage and negative voltage regulators. So this ICs can helpful for producing the consistent or constant voltage at the output end. In the analog processing, we can do the continuous signal amplification, filtering process, and conditioning enable precise control in real-time applications. The filtering means you can pass the low pass or high pass mid band frequencies, so that can be helpful by LICs. Then in terms of key applications, we can have the analog systems, power management, sensor interfaces, and communication equipment rely on LIC technologies. So next comes the convergence LIC meet modern technologies. Here we can have the three kinds of areas. One is artificial intelligence and machine learning, then IoT, then deep learning. So the integration of linear ICs with the cutting edge technologies is creating smarter, more efficient systems. So with respect to artificial intelligence and machine learning, the intelligent signal processing enables adaptive systems and predictive maintenance capabilities. So we can build the adaptive systems using this linear integrated circuits. So with respect to this IoT, we can do low power, high performance connected devices worldwide. So for this field, the LICs will be more reliable for constructing the IoT systems. And for deep learning, it can optimize the complex analog circuit design and enables real-time anomaly detection. So now we will be discussing the role of ICs in artificial intelligence and machine learning. So it enhances the signal processing for AI algorithms. So once the AI algorithms can be built, it can be demonstrated with the help of ICs. So here the ICs plays a vital role in constructing this artificial intelligence systems, so that you can have the faster low power operation of neural networks, and this it facilitates the edge artificial intelligence with efficient on device processing, then enable adaptive and autonomous AI capabilities, then supports real-time predictive maintenance. So these are the some of the key responsibilities of integrated circuits on these areas. Then we will be discussing about the role of ICs in IoT. So you know that the IoT can connect billions of devices. So for that, the low power LICs can be used to construct this kind of more number of devices together, and also it enables the high performance wireless connectivity so that you can communicate without any delay between the two devices. So to construct those systems, these ICs are mostly used, and also it can construct the smart homes, cities, and industries, and also it improves the data collection and real-time analysis. So for the real-time analysis, this IC can be more useful, and also it optimizes the power consumption for IoT devices. Uh, this slide shows the LIC's role in deep learning architectures. So it can accelerate the neural network training and interfaces, and also it optimizes the analog circuits for deep learning applications. So for constructing this architecture, this analog ICs are mostly used, and also it enables the real-time processing for large data sets. So if deep learning comes into picture, the data set may be very large. For the processing should be very fast to solve those issues or handling the data sets. This ICs can be more applied, and also it enhances the anomaly detection with increased accuracy. So here the AI powered LIC design for smarter circuits and faster innovation. So here we can discuss this topic into three categories. One is neural network accelerators, automated design, and predictive modeling, for which for the neural network accelerators, we can have the MAX 78000 and MAX 78002. It brings the AI interfaces to the edge, enabling real-time decision making in battery-powered devices. For the automated design, the machine learning algorithms optimize analog circuit layout and performance. It reduces the design cycles for months to days. And also for AI forecast circuit behavior and identifies the potential failures before they occur, improving the reliability and reducing the cost. So this can have the three few applications which we are discussing in this forum. One is smart healthcare and industrial automation and smart cities. So in the smart healthcare, the LICs are used in wearables design and real-time health monitoring, then AI-driven diagnostic and preventive care. For the industrial automation, it can be powered by AI enhanced LICs, which reduces downtime and save millions. And for smart cities, the efficient power management can be done, and the sensor network, which enables the sustainable urban development. So thank you for passion listening. I hope this video is helpful for how this LICs can be applied in various applications. I mean the recent technologies. Thank you all.